Okay, welcome to Proposition 14. Proposition 14 is going to prove that if you have a hyperbola, the parts of either of the two sections, one on the top part of the conic surface and one on the bottom part of the conic surface, are the same or equivalent. So we're going to prove that the diameter of the two sections is the same line. This transverse side, HE, is common to both of them, and most importantly, that these kickstands, or upright sides, are constructed equal to one another. So first I'm going to go through the construction because it's a little bit different than what we've been doing in previous props. So first we're going to have the generating circle and the conic surface made from the line revolving around it. And then we're going to create some plane on the opposite side of the surface that the generating circle's on, and we're going to create it parallel to this plane, which was BC. Over here it's this plane BC. So then we have this cutting plane, and then we have another cutting plane, which is going to be where the hyperbola is. So I'll draw the hyperbola. And the hyperbola will make these sections, and then we will draw from one center of this circle to the other center of this circle the axis through the vertex A. And then from these centers, and these are the lines that's between the section of the cutting plane and the section of the circles, is a straight line. And we're going to draw a diameter of these circles such that when it cuts this straight line, it'll be perpendicular. So just to be clear, over here on DF, we constructed BC, the line diameter BC, perpendicular to the line FD. So we had this one first, and then we constructed this one. Same thing on this side, a diameter perpendicular to this plane of the section, and that will make this diameter parallel to this diameter because they were both constructed perpendicular to the same plane. So now that we have our diameters, we're going to construct lines to the axis, and we're going to create these axial triangles. Over here, the axial triangles would be AXO and ABC. And then once we have those axial triangles, the section where the plane of the axial triangles cuts the plane of the cutting plane, where the hyperbolic sections are, that's going to create our diameter, and it will be NHEM. And that is a straight line because it's a plane cutting another plane, results in a straight line, and it's the same line. So we've checked off two of our two proofs just with the construction. And to check off our third, which is the upright sides are lines of equal length, we're going to do some ratio manipulation. So we've already got this construction for the kickstands. We're going to create the kickstands EP and HR from the vertexes H and E, and they'll be constructed like this. Then we're going to look at some similar triangles. We're going to look at ATX and ACS, which are similar because these are vertical angles, and these were constructed parallel to one another because I think it was the plane XO was constructed parallel to the plane BC. So we have as AT is to TX, AS is to SC. And then let's highlight some other triangles, ATO and ABS. Similar for the same reasons, vertical angles, parallel lines. And as AT is to TO, AS is to SB. Now we're going to take square AS rectangle BSSC and write this out as a compounded ratio instead of as figures. And that will be as the square AS is to the rectangle BSSC, the ratio AS-BS is compounded with the ratio AS-SC. And again, this is because if you wrote this out, AS times AS over BS times SC equals AS over BS times, compounded means times, AS over SC. This just makes it more visual. I'm just doing this as a little review in case you haven't seen the previous videos. Anyway, so let's do that with this now. So the square on AT is to the rectangle OT dx as the ratio AT OT is compounded with the ratio AT TX. Okay, great. So ATTX, or AT is to TX as AS is to SC. So that means that this could be substituted with this, and ATTO, AT is to TO as AS is to SB. So that means that this could be substituted with this. So this compounded with this means the same thing as this compounded with this. So we're gonna say that these two have the same relationship also. So let's rewrite that as the square on AS is to the rectangle BSSC, the square on AT is to the rectangle on OT TX. And now let's substitute the right sides for the left sides. So the square on AS is the rectangle, the square on AS is to the rectangle BSSC as HE is to AP. So and the square on AT is to the rectangle OTTX as the line HE is to the line HR. And HE is here, and HE is here. So if something has the same ratio to equals, then they are equals. So that means that EP is equal to HR. Let's rewrite that up here. And EP is this kickstand, and HR is this kickstand. So the kickstands are equal, and that's QED.